In this lesson, we're looking at working with functions and formulas. Formulas are equations that use variables, which we replace with numbers. They have important applications in business, technology, science, medicine, and many other fields. These formulas may be represented mathematically by functions such as polynomials, exponentials, etc. So you've worked with many formulas throughout your years of math education, including measurement formulas, geometry formulas, that type of thing. In this first example, it says the formula E equals I squared RT determines the electrical energy in joules, E, in an electric circuit, where I is the current in amps, R is the resistance in ohms, and T is the time in seconds for which the current flows. First of all, it says isolate the I in the formula. So in other words, in part B, we're interested in solving for the current. And so it would be helpful if we could have this formula written in terms of I and not E. So right now, the formula is E equals I squared RT. If I want to isolate the I in this equation, then I will start by dividing both sides by RT. So now I know that E over RT is equal to I squared. So then to get I by itself, I would need to take the square root of E over RT. And then in part B, when we're trying to find the current in the circuit, if there is an electrical energy of 1600, so 1600 is our value for E. R is the resistance, which is 10, and the time is 40 seconds. So we're going to replace all those values in the formula that we found in part A. So it will be the square root of 1600 over 10 times 40. So the square root of 1600 divided by 400, which means we need to find the square root of 4, which is 2. So therefore, the current is 2 amps, because it tells us in the question that the current is measured in amps. In the next example, I have a formula that applies to cameras. So in this formula, F is the focal length of a lens, A is the distance from the object to the lens, and B is the distance from the image to the lens. And we are asked to isolate the variable F in this formula. So right now, this formula is written as 1 over F is equal to 1 over A plus 1 over B. The first thing I would want to do is combine the two fractions on the right-hand side of the equation. So I would use a common denominator of AB. So in the first fraction, I've multiplied my denominator by B, so I must multiply the numerator by B. Second fraction, I've multiplied the denominator by A, so I'll multiply the numerator by A. So now I have 1 over F equals B plus A over AB. So if that's 1 over F, then F would be the reciprocal of that. So we're just going to flip the fraction on the right-hand side. Okay, and that concludes this lesson.